Hello and welcome back to FRDC at Home, a video series that explores different aspects of the living, working Fraser River, from its industry to its wildlife and ecosystems and the people that call the river home. This one that we're doing today, which is all about geology, is part 2 of a 3-part video series. So if you haven't seen part 1 yet, I highly recommend you checking it out first so that some of what we're going to be talking about today have a bit more context and make a little bit more sense. Before I jump in though, I would like to take the moment to acknowledge that the Fraser River Discovery Centre is located on the traditional and unceded territory of Hulkamalum and Hunkamanum speaking peoples. Now it's important to note that territory acknowledgement is just one small part of reconciliation, so I encourage you all to think of some of the other ways that we can engage with reconciliation with Indigenous communities in British Columbia and across Canada. So this activity that we're talking about today is all about a process called rock weathering. So there's going to be a science experiment involved as well, which we'll get to in just a moment. The list of all of the materials you will need are in the video description, but I'll go through it before we jump in, so don't worry about that, we'll have it covered. From mountain ranges to caves, sandy beaches to canyons, rocks are everywhere. But why do all rocks look different? You know, when you go out, you don't see a bunch of identical rocks all over the landscape. There are big ones, there are small ones, there are hard ones, there are crumbly ones, rough ones, and smooth ones. There's a huge variety in the types of rocks that we can encounter. So for this activity today, and this presentation, we're going to look a little bit at some of the different types of rocks you can find and how they're made, as well as how they are impacted by physical and chemical weathering. So the first question to ask is, what are rocks? So rocks are made up of many different types of minerals, minerals being materials that occur naturally in the earth. So a way I like to think about it is, imagine a rock like a cupcake. And in the same way that a cupcake is made up of flour and eggs and milk, rocks are made up of all of these different individual minerals that come together to form a specific formation, in this case, a rock. Now, there are lots of different types of rocks that exist in the world, but for our purposes today, I want to talk about 3 main types of rocks. They are sedimentary, metamorphic, and igneous, and we're going to go through each one in turn to learn a little bit about what they are and how they form. So sedimentary rocks occur when many different small rocks and gravel and sand and sediment come together in layers over an extended period of time, and through pressure pushing from all sides they form individual rocks. So sandstone is a great example of a sedimentary rock. Originally it was small components that have come together to form a single solid. So the next type of rock I want to talk about is metamorphic rock. Now, metamorphic rocks form when a rock, usually sedimentary, is subjected to even more pressure as well as intense heat. So if you take our sandstone from earlier and you subject it to even more compression from all directions, and you add that important element of heat, and then you can get metamorphic rock. So some examples of metamorphic rocks that we can see in the natural landscape would be lapis lazuli, gneiss, quartz, or even marble. Some of you may have marble somewhere in your homes, in your apartments. Appliances, tiles, countertops could be made of it. So we can have a lot of use for the kinds of rocks that are created which are metamorphic. Now, the third type of rock is called igneous. Now, igneous rocks form when the heat, we were talking about earlier with that pressure and heat, the heat though gets so high and so intense that it actually melts the rock and it turns into a semi-liquid state known as molten. So a great example of molten rock would be the lava that we find in volcanoes. Now, when it's underground, when it's inside the volcano itself, before it erupts, lava is known as magma. But then when that explosive eruption takes place and this molten rock comes out of the earth, we know it as lava. And lava is a great example of this molten rock, this igneous rock. Now, as the lava collects and flows down the volcano's sides, it will cool and solidify. And this solidified rock that we get at the end is just the end point, the example of igneous rock that we're talking about. So obsidian is a really great example of igneous rock. And in the Fraser watershed, First Nations and Indigenous communities learned how to use some of these rocks in their technology, in their tools. So you'll sometimes find projectile points that were used sometimes for spears, sometimes for fishing, sometimes for hunting, and a variety of other means as well. And a lot of the tips, the hard pointed tips, were made of igneous rock. So rocks are everywhere. Mountains, canyons, coasts, caves, caverns. You can't walk 10 feet without being in close proximity to at least some kind of rock. And they take all sorts of different shapes and sizes. Now, have you ever wondered though, why no two rocks look the same? There's lots of variety, not only in the types of rocks, sedimentary, metamorphic, and igneous, but also in the way that they are affected by their environment. So like a huge boulder that rolls down a mountainside and breaks down and crumbles into smaller and smaller pieces and chunks, and by the time it gets to the bottom, it might be no more than a big pile of sand and gravel. So this is because rocks are subject to a process called weathering. Now there's different kinds of weathering as well, but for today we're going to be talking about two important types of weathering: physical and chemical. So physical, kind of, it's in the name, it's the physical breakdown of rocks due to outside forces and pressures and actions taking place. So heat, water, ice, and wind, those would all be examples of physical weathering. So a great way to imagine this is when you go down to a pebble beach and you find a lovely smooth pebble that you want to skim and see how far it will go. Well, that rock didn't start out that way. It didn't start out that lovely smooth round shape. It would have started out as any number of forms, but rough and coarse and jagged. But usually, in this case due to water, such as the ocean or such as rivers, over time, this constant friction of the water and the rocks grinding against other rocks as well have smoothed it down to that lovely pebble that we can then use to skim. So that's a great example of physical weathering. Now, the other kind of weathering is called chemical. So chemical weathering is the breakdown of rocks through changes to the tiny mineral makeup of the rock. So another way I like to think about it is, let's say you have a bowl of cereal like Rice Krispies, and you pour milk on the Rice Krispies, and you hear that snap, crackle, pop that happens as the second the milk hits the Rice Krispies. The Krispies aren't being ground against each other. There's not this huge rush of water that's pushing them against each other to grind them down. The presence of the milk, the liquid, causes an immediate reaction, a chemical reaction that changes the shape and the state and the structure and the softness of the Rice Krispies. So that's a great example of chemical weathering. Okay? So, to learn more about weathering, particularly these two kinds, we're going to be doing a little bit of a science experiment. We're going to be using some sugar cubes as stand-ins for rocks, and we're going to be exploring how both physical and chemical weathering can cause rocks to change their shape and break down over time. So, let's get into it. So having learnt about the three different kinds of rock, now we are going to be doing a fun little science experiment to help explore the two different types of weathering that we talked about. Now, as I said earlier in the video, all of the ingredients and the materials that you need for the science experiment are in the video description, but I can show you what we need today. It's very, very simple. So, you will need a black working surface. This could be a countertop, or you could use paper. So I'm using black construction paper to make my little workstation so that we can see very clearly what's going on. We'll also need our rock. So I am using sugar cubes. You don't need many for this experiment. 2 to 3 should be more than enough for our needs today. And you'll also need water in a little beaker or in a little cup. You can also use a little dropper or a spoon to move the water if you want. My little beaker has this little flute, so I can drip the water onto the rocks today. If you don't have that, you can use a spoon as well. So the first type of weathering that we're going to be doing is physical weathering. So you can do it as I do it, you can watch me and then try it out yourself, doesn't really matter. So the first thing you do is you take 2 of our lovely little sugar cubes, which are our rocks. And what we want to do is we want to start to grind them against each other. Because these sugar cubes have very straight edges and very sharp points. Kind of like how a jagged rock might have if you find one out and about on your adventures. But as we know from those smooth stones that we can find, on a pebble beach, when rocks are subjected to physical weathering, they smooth down over time. So you're grinding your rocks against each other, and as you do, this is where the black working surface, such as my paper, comes into effect. Because as I'm grinding the rocks together, we can see that this sediment, all the little dust and the stones and the pebbles from our rock are being ground away, and we can see it form very clearly. So this is a great example of the kind of rock weathering that takes place on sedimentary rock, which is those layers, because as it breaks down, you can see the sediment being formed. So this is a very simple demonstration of the physical aspect of rock weathering. So you can try it out for yourselves, or you can pause the video and give it a shot, but that is physical weathering. Now, the second type of weathering, chemical, this is where our water comes in. Now, you might be thinking, but isn't water another example of physical weathering? Because water can affect the rocks, and you'd be right, but we're not going to do anything to grind down or to affect the rock in a physical sense. All we're going to do is we're going to take our water, and we're going to take just a few drops. You don't need all of the water here, and we're going to pour a few drops on our sugar cube, and we're going to wait a few seconds and watch what happens without touching the sugar cube at all. Okay, so let's find out. So just a few drips, and you might notice almost immediately that the sugar cube is starting to sag. It's starting to change its shape ever so slightly. And I haven't touched it, I'm not pressing it, pushing it, grinding it. All I'm doing is putting a little bit of water on. And we can see that the sugar cube is actually collapsing as the water breaks down the connections, the sugar that's holding the whole cube together. And you can see if I touch it now, it has completely lost its shape, and it's just turned into this sugary, watery mess. If I left it long enough, a lot of the sugar would start to dissolve, and it would be dissolved into the water, and we couldn't actually see the fragments of sugar at all. So that is an excellent example of chemical weathering. Not a physical reaction taking place, it's all a chemical reaction. And you can try that at home. You can try it with as many sugar cubes as you want, but bear in mind that you will have to tidy up afterwards. It does create a mess, and it gets very, very sticky, so bear that in mind. But I hope you enjoyed our little science experiment today. I hope it gave you a good idea of the different types of weathering that can affect rocks, and I hope you've learned something new about the different types of rocks that we can find along the Fraser River. So thank you very much for joining us, and we'll see you next time.